Get the proofs on here. Now that we've gone over all the rest of them, let's go through the proofs together, okay? Some of these proofs were a bit tricky, so that's another reason why I kind of wanted to take the opportunity for us to go through them now. So, have your worksheet out. Make sure you're with us, not doing anything else on your iPad, but instead following along with us when it comes to these proofs, okay? All right, so let's start with 8. We did 1 through 7 on the board already. Let's do 8. So 8 was one of the longer ones. It was a fill-in. Do you have this worksheet? From yesterday. Have that out so we can go over it. Okay. You guys ready? Albers. All right, what's our first reason? Yeah, so we start off by saying given. Okay. All right, and then so it says those lines are perpendicular to each other, and then it doesn't. You all right? Okay. It doesn't list your second given straight away. Where was your other given at? Yeah, so the third one is also given as well too. Okay? So you had to recognize that they kind of split your givens apart. Okay? All right. Now, what did they use for number 2? Yeah, that's angle addition postulate. Good. So angle addition postulate is what allows us to add 2 angles together to equal a larger angle. Okay. All right. If I know angle 1 and angle 2 are complementary, what can I say? Yeah, so the next one would be definition of complementary angles, because angle 1 plus angle 2 would be equal 90. So this would be definition of complementary angles. Okay. All right. And then after that, let's see. It says measure of angle ABC equals 90 degrees. How can we justify that? Yeah, I'd be cool with transitive. Transitive or substitution. Either one of those would be perfectly fine. I'm going to use transitive, though, because we know that ABC equals 1 plus 2, but 1 plus 2 equals 90. So then I can say ABC equals 90. So transitive property would be just fine. All right, and then after that, number 6, BA is perpendicular to BC. What'd you guys say for that one? Yeah, I like that. Definition of perpendicular lines, because we know that it forms a right angle there. So because it's a right angle, by definition of perpendicular lines, they got to be perpendicular to each other. So definition of perpendicular lines. Very good. Okay, and then we concluded BA is parallel to CD. Now this one was a bit tough. This one we had to use that theorem that I taught you toward the end of class yesterday, which said if you have 2 lines that are perpendicular to the same line, then those 2 lines are parallel to each other. And there was an abbreviation of that, which wasn't very short, but it would be 2 lines perpendicular to same line implies parallel lines. That was our abbreviation for that theorem. Which basically just says what the theorem states itself, okay? All right, and then again, here's a look at 9 and 10. 9 are parallel. 10, when you actually find your average rates of change, you'd find that this line has a greater average rate of change than the other one, so they end up not being parallel to each other, okay? All right, more proofs in the back. That's where most of the proofs were housed. Okay. Some of them were short, and then others were not as short. So, okay, number 1, I know angle 1 is congruent to angle 2, and I know angle 1 is congruent to angle 3. How could I say that angle 2 is congruent to angle 3? What you guys put for 2? Substitution's the better one to use there instead of transitive, so I agree with Liam. Mr. Moped, substitution property. Are you trying to get a moped? Is that why you brought that up earlier?
No, he was just joking.
Okay, what a guy. All right, AB is parallel to DC. That's what we ended up wanting to prove. So now what we actually need to do is we need to go through and we need to look at our picture. So it says that angle 1 is congruent to angle 2, and then we went on to say that angle 2 is congruent to 3, and we wanted to prove that AB is parallel to DC. So now you guys need to tell me what type of angles do I have with angle 2 and angle 3. What do you think? And if you're unsure, let's break that lasso out and move that over there. What type of angles are those?
Alternate interior.
Very good. So we would say alternate interior angles congruent implies parallel lines. Okay. All right. All right, numero dos on the back. Okay. 15 is congruent to 5. What's our reason? Woo. 13 is congruent to 15. That wasn't one of our givens, was it? Okay. Let's see. So 13 congruent to 15. Why is 13 going to be congruent to 15? It's not substitution yet. We're going to do substitution at some point, Landon, but not yet. What kind of angles can you guys tell me about 13 and 15?
Vertical angle.
Yeah, good. So we'd say vertical angle theorem, okay? And then it goes on to say that 5 is congruent to 13. What's that going to be, Landon? That one is substitution. Okay? And then it says R is parallel to S. So what that means to me is, okay, the statements that they just fed us proved that lines were parallel. So I probably have one of those angle pairs, whether it's like corresponding, consecutive interior, alternate exterior, in the step above it. So I would go through and I'd look at 5 and 13, and I would say, okay, 5 is here, 13 is there. What type of angle pairs are those, 5 and 13? Very good, corresponding. So then I would say corresponding angles congruent implies parallel lines. My arrows are never good. That's pretty good. It's not bad. All right, and then 5, your reason is given? So weird practice, right? Usually we list all of our givens first. They did it later in the proof. Whatever. What's our other given statement that we didn't use? Hiya? Good. Angle 1 is congruent to angle 5. So that's our other given. And then the last one, we got to fill in the statement, and it talks about corresponding angles. So it says, if corresponding angles are congruent, then lines are parallel to each other. Well, shoot, man, what did I want to prove? Right, because I already did R is parallel to S. So I need to prove the other thing that's in there, which is L is going to be parallel to M. Okay. All right, so then that was 2. Questions there? And now, for the shortest proof you guys have ever seen. Anybody bring a cool water bottle for Spirit Day?
Should have brought like a gallon of water. I brought it.
This would have been your day to do that. What'd you say, Braden?
I had an invisible water bottle.
Oh, nice. You know what I was going to do? This is what crossed my mind, because school spirit's important to me. So I was like, I need to participate. I will bring something. What should I bring as my water bottle? And what I was going to do is I was going to bring a rag. And then every time I want to take a drink of water, just get the rag wet. But then I figured I'd get that reaction pretty quick. And I'm like, no, I'm not going to do that. So anyway, first one. Angle 2, comma, angle 3, supplementary. Let's abbreviate that.
You know Heinz wants to make a clear ketchup?
Clear?
Yeah.
Come on, I've already heard this in French class. I don't need to hear it again.
That's crazy. All right, hey, if angle 2 and angle 3 are supplementary, that's like what I want to show, right? Like it says prove that AB is parallel to CD. What type of angles are angle 2 and angle 3? Supplementary, yes, they gave me that, but what else? What type of angle pair?
Linear.
Not linear.
Consecutive.
Consecutive interior, right? So because of that, well, shoot, man, I know that if consecutive interior angles, like I'm going to write the reason first. Consecutive interior angles supplementary implies lines are parallel. And that's what I wanted to prove. I want to prove that lines are parallel, so then I can say that AB is parallel to CD. So that was a really short one.
So, I definitely didn't do that.
No.
If I did this, would it be wrong?
What'd you say? 2 and 3 are supplementary, and then you went to 2 and 4.
And then 4 and 3 are through substitution are supplementary, and then these are equal because
You can't really compare 2 and 4 together. Look at the board. So if you do 2 and 4, 2 and 4 connect to.
4 and 3.
Oh, 4 and 3.
I compared 2 and 4 because they are on the opposite side of the transversal. And
4 and 3 wouldn't really work either because they are, like, if you look, so they're here 4 and 3, and there's not a transversal that connects 4 and 3. That's what you would need. So that wouldn't quite work. So don't do that, please. That's all right. Okay. Let me pass out your review. I'm gonna do some of these with you guys, and then I'll give you guys time at the end to. Actually, we're gonna do this part first, because we'll go through this fast. I think so. Yeah. All right. Let's do a quick practice with angles, which will not take you very long to do at all. Yeah, like we're just gonna rip through the front and say whether or not these are parallel or not parallel.
Rip through it? Oh, maybe that's what you said.
We're gonna go through these fast. We're just gonna do them together collectively as a class. Thank you guys this year. All right, look at the worksheet in front of you. Okay, so we're literally gonna do 1 through 14 like together real quick. It's gonna go really fast. Okay. What we want to do is we want to say whether or not these lines are parallel to each other. All right, let me pull this up. Here, take a couple minutes while I'm pulling this up and look through them right now, 1 through 14, and decide whether or not there's enough information to say that those lines are parallel. If you want, work with the people that are at your tables.
Yes. Actually, what he said. That's funny.
Yes, they are. Yes. So look, it's good right here, so then that's 120. So then they connect, and then equals. You're on this one? Yes. Oh.
These ones aren't either.
No, they are. They have to. Oh, shoot. Yeah.
All right, how we feeling? We done? Not yet?
10 minutes.
Oh, no, not 10 minutes. We can do it quick in 10 minutes. Did I say 4 minutes? I don't know what I said. But either way. What'd you say? Yeah. That is what I said. However long it takes for me to pull up. Okay, here we go. Let's see how we did. Now, what you guys are doing is you're looking for, like, okay, evidence in the picture. Either these lines, I could look for angles that are supplementary to each other. I could look for angles that are congruent, and I got to figure out how I'd name these pairs of angles, okay? There's 14 of them, and there's 14 of you in this class. There's more than 14 of you, actually. Speaking of which, I got to take attendance.
That sounds like something we'd say though.
I seem to give it to the most intelligent person in the room.
Yeah, who do you think would say that?
You have until I'm done taking attendance. Here we go.
Why do you do such a
Who am I missing? Angeline, and that's it, correct? Just Angeline. Okay. All right. Here we go. Probnor starting with number 1. What do you got, Probnor? Are they parallel or not? Why? What type of angles are we working with here? Good. Thanks, Max. Alternate exterior angles congruent, imply parallel lines. Yep. Got to say yes, and then you got to tell me why. Tell me why ain't nothing but a... All right. Caden, number 2. What do you got, pal? Why? They are alternate interior angles, except in the picture, they're not congruent. Because it shows you that one is 100 and one is 80. I would want them to be the same. So they are alternate interior angles, I agree. But since they're not congruent, we got to say no, angles are not congruent. All right, cool. Tegan, you're number 3.
No.
Mads, you're going to be number 4. You said no, Tegan?
No.
Why not?
Because wouldn't they have to be congruent?
They would have to be congruent because they're what type of angles?
Corresponding.
Good. So we would say no, corresponding angles are not congruent in my picture. So those lines are not going to be parallel. All right, Mads, let's look at number 4. What type of angles do we have in number 4? Not corresponding. The other one that starts with a C, though. Right, they're consecutive interior angles. Now, what do you guys know about consecutive interior angles? They have to be what? Right, supplementary, right? Maddie, do those add up to equal 180? No. Because one's 82, the other one's 102, so it's not going to work. So we would say no. Consecutive interior angles are not supplementary. So that's a no. All right, moving right along. Haya, let's go to you next. What about number 5? Nice. So yes, with an exclamation point. Alternate interior angles congruent imply parallel lines. Nice. Albers, we're going to you next. What about number 6? They are indeed parallel. What type of angles do you have? Good. Corresponding angles. So corresponding angles congruent imply parallel lines. You're worse than my 7-year-old, Probnor.
What did I do?
My 5-year-old's learning to read right now. And so when I'm like trying to like read with her, Lucy, my 7-year-old, who's an overachiever, will be like, just like reading the words for her. And it's like, Lucy, no, I know you're excited because you know how to read. And you're doing the same thing.
I was the same kid.
It's all right. Landon, number 7. They are a linear pair. I agree with that, right? Good, because,
They also equal.
yeah, so they equal 180, right? If you add them together, they equal 180. But does that tell me that, like, for example, look on the board. Does that tell me that line L and M would be parallel to each other? No, because does that tell me anything about M? No, so linear pair is not going to help me out there. Great job, Landon. So we'd say no angle on, we can just say line M. So linear, or better way to say it would be linear pair doesn't tell me that the lines are parallel. Maxwell, 8. No, why not? Good. Alternate interior angles not congruent. Christian, what about 9?
Yes.
Nine's kind of a tricky one, you know? Because do I have any angle pairs that relate those two angles together? Like, those aren't corresponding, right? They're not alternate interior. They're not alternate exterior. They're not consecutive interior. However, let's move that 100 degrees around. Where could I put that 100 degrees at? I could very easily put it like right there, right? And then if I put it right there, what do you know about these angles? They would add to equal 180 and they're consecutive interior angles, like you said. So we could say, yes, consecutive interior angles, supplementary, imply parallel lines. Okay. All right, number 10. Kyle Cunningham, number 10. What type of angles do you have in number 10, Kyle?
Vertical?
They are vertical angles. Is that going to tell me that lines are parallel?
No.
No. I mean, that tells me that they're vertical angles, but that's it. So we would say no, vertical angles does not imply parallel lines. All right, Ryan. 11.
Did I do 12?
No.
I did 11.
No. Well, so like that was kind of similar to Christian's. I don't know anything about that angle pair, right?
Not really.
And it also doesn't tell me that those angles are congruent even still, right? So is there anything I can get from that? So I would say no. I'm just going to say not enough information. All right, Liam, 12.
No.
Why not?
What was it?
11's where we're just going to say no, not enough information.
Yes.
They are indeed parallel to each other. Dom's going to help you out. Dom, why are they parallel?
Supplementary.
Yeah, and they're what type of angles?
Consecutive interior.
Good. So we'd say consecutive interior angles supplementary imply parallel lines. All right, Braden, before you fall off the face of the earth, tell us about 13.
No.
Why not?
Not enough information.
Yeah, like they're not congruent, which is good, but does it tell me they're supplementary? No. So we can say no, not enough info. I'm fine saying that. All right. Clark, number 14.
The only one I didn't do, really.
That's it. I'm going to help you out with it, though. So if angle 1 is congruent to angle 2, if I draw more in my picture, is this line parallel to this line? If I connect them by a transversal here. What type of angles are they?
Alternate interior.
Good job. Alternate interior angles imply parallel lines. See, you knew how to do it. Good job, Clark. Julia, you got off easy. Oh, wait, there's more. Okay, so, hey, let's look at, all right, let's look at 15, 16, and 17. Oh, and then there's also some down there as well, too. Okay. All right, we'll spend a couple minutes on these. I don't know if I'll go through all these because I have a different worksheet that I want you guys to work on for the last 15 of class. But we can talk about these real quick. So, like, you guys tell me, number 15, I'm not actually going to set it up and solve it, but what equation would I set up to solve for x in number 15?
80 plus x minus 15 equals 30.
Yeah, I'll write it out. So 80 plus x minus 15 equals 180. Because those are consecutive interior angles, add them together, set it equal to 180. Good job. What about 16? What would I do?
X plus 1 equals 110.
Good. X plus 1 equals 110. Good job. Oh, it's easy. X equals 109. And then 17, we got a bit of a fill-in proof. So I tell you that 1 is 115 and 2 is 65. Those reasons would both be given. And then it says 115 plus 65 equals 180 degrees. We could do angle addition postulate. I'm trying to think of the best way for us to justify that. Yeah, let's do... I actually wouldn't use angle addition postulate there. I would just use, I mean, really, we're just adding two numbers together and showing that it equals 180 degrees. So, you know what? Angle addition postulate's fine. Angle addition postulate's fine. We can do that. Those two angles added together. And then we replace the 115 and the 65 with the names of those angles. So I would say substitution. All right, and then it says, okay, 1 plus 2 equals 180, so then 1 and 2 are supplementary. What reason would we justify for 5? I know that two angles added together equal 180. Just definition is supplementary is what I would use. So def of supplementary. Okay, 1 and 2 are here and here. What type of angles are 1 and 2? Good. So then that's when we would use consecutive interior angles, supplementary, imply parallel lines. Okay. All right, 18 and 19 is more of the similar stuff. I'm going to skip those and rather give you guys time to work on the worksheet I'm signing you guys tonight. Okay? All right, a little quick in-class practice. I thought we could do some quick hitters with those angle pairs. So